What is the new pH of your stomach if you drink soda, and how much did it change by? pH is a scale to measure how acidic or basic a solution is, to 14, 1 being very acidic and 14 being very basic. A pH of 7 is neutral. To calculate the change in pH, you need to know two of the following: pOH, the concentration of hydronium ions, or the concentration of hydroxide ions. We know that stomach acid has a pH of 2 and that soda has a pH of 3.9. Let's say you drink 100 milliliters of soda and there is about 100 milliliters of stomach acid inside your stomach. Because this reaction takes place in an aqueous solution, we can use the water autoionization. Water autoionization reactions is basically water reacting with itself. It's H2O plus H2O yields hydronium ions and hydroxide ions. This does not affect the other reaction, but by monitoring water ionization products like hydroxide, we can then backtrack to the amount of reactants that reacted in the main reaction, in this case soda and stomach acid. Step 1. Find the concentration of hydroxide and hydronium ions. Soda has a pH of 3.9. So we can find the hydronium ion concentration, which will give you the concentration of hydronium ions, which is 1.2 times 10 to the negative fourth. For stomach acid, you need 2 is the pH, so pH plus pOH equals 14, so 2 minus 14 equals 12, which is the pOH. And then for the concentration of hydronium ions, it's the same thing, 10 to the negative 2, which equals 0.01. And then for finding the concentration of hydroxide ions, it's 10 raised to the pOH. So for soda, it'd be 10 to the negative 10.1, which equals 7.9 times 10 to the negative 11th. And for stomach acid, it would be 10 to the negative 12th, which equals 1 times 10 to the negative 12th. Alright, next we need M1 plus V1 equals M2 plus V2. So we're going to take the 100 milliliters times the 0.01 molar hydronium ions, which equals 0.001 moles of hydronium. That's from the stomach acid. And then 100 milliliters times 7.9 times 10 to the 11th hydroxide, which equals 7.9 times 10 to the negative 12th moles hydroxide, and that's from the soda. So then you take the moles of hydronium minus the moles of hydroxide, which equals 1.0 times 10 to the negative third moles of hydronium remaining. So the concentration of hydronium is equal to 1.0 times 10 to the negative third moles hydronium over 0.2 liters. And the 0.2 liters is from the 100 milliliters of stomach acid plus the 100 milliliters of soda. Anyway, that equals 5.0 times 10 to the negative third molar. To get the pH, we take the negative log of 0.005, which equals a pH of 2.3. So the new pH of the stomach is 2.3. And then to find the change in pH, we take 2.3 minus the original pH of the stomach, which is 2. So the change in pH is 0.3 after drinking 100 milliliters of soda, which had a pH of 3.9.